Okay, this is part 3 of Unit 1B. I'm looking at propositions, truth values, truth tables, and we are now to conditional statements, which are more known as if-then statements. And when we look at this, our if-then statements, here's a unique one we could throw out. That's not unique, but if all politicians are liars, then Representative Smith is a liar. So again, we have two propositions. All politicians are liars. Representative Smith is a liar. So we have P, then Q. Again, the truth of those, P and the truth of Q, okay, that's dependent upon our situation. But again, these statements are called conditional propositions or implications because they propose something to be true, which is the then part of the statement, on the condition that something else is true, which is the if statement. And these are ones we have to look at carefully. Now we can represent a conditional proposition if P then Q, with proposition P being called the hypothesis or the antecedent, and Q being the conclusion or the consequent. So now we're going to look at an example here to try and decipher, come up with this truth table right here for if P then Q. And some of these aren't as straightforward and intuitive as you would think. And so we're going to be looking at the propositions. So we're going to be looking at this conditional proposition or implication that says, if I am elected, then the minimum wage will increase. Okay, so our P is if I'm elected, then our Q is minimum wage will increase. And it says that right here. So let's look at the first scenario. If P and Q are both true, so if the person is elected and the minimum wage increases. Okay, so in this case, again, Jones was elected, whoever this Jones candidate is running for Congress, and the minimum wage did indeed increase. So Jones kept the campaign promise, so her claim, if I'm elected, then the minimum wage will increase, is true. So that's why down here, if P is true and Q is true, then, so P is true, Q is true as well, then the proposition if P then Q will always be true. The next statement down here, if P is true, Q is false. So this is number 2. In this case, Jones is elected, but minimum wage did not increase. Because things didn't turn out as she promised in this, then we have a false statement, because the first proposition, she was elected, is true, but she did not follow through on the minimum wage increasing, so this is false. So if P is true and Q is false, then if P then Q is false. And that's actually the only time this is false, is when the hypothesis is true and the conclusion or the consequent is false, then the if P then Q is false. So this is where things get a little bit different, is in number 3. If P is false and Q is true. Okay, let's look at this. This case is where Jones is not elected, yet minimum wage still increased. So the conditional statement makes a claim about what would happen in the event that Jones is elected. Because she was not elected, she surely didn't break any campaign promise, regardless of whether or not minimum wage increased. So the rule of logic here is that we consider Jones's claim to be true, because she didn't break any promises. So if the claim initially, if we have false for P and true for Q, then the end result there if P is false, then then Q is true, that is true. And that one really kind of goes against the logic. You really have to think about that. But again, this is just a rule of logic. Now, lastly, if P and Q are false, now we have the case in which Jones was not elected, minimum wage did not increase, but again, because she was not elected, she surely didn't violate her campaign promise, even though minimum wage didn't increase. And so just as in the previous case mentioned before, Jones's claim is true. So really, if you're looking at this and your hypothesis, if it's false, which occurs in these two instances right here, then you automatically have a true statement. Excuse me. You automatically have a true statement in your conditional proposition or implication. So again, if it starts with false, doesn't matter what the result is on the conclusion, that proposition, the conditional proposition will always be true. So again, we have true, false, true, and true. Again, that one just takes a minute to wrap your head around. But just trust it for now. If you don't fully get it, trust the concept for now, as more will come later. Okay, so now we want to identify the hypothesis and the conclusion. Well, we want to identify the hypothesis and the conclusion, and then we want to state the truth values to determine whether the entire proposition is true or false. So if Paris is in France, that's true. Then New York is in America, that's true. So again, in our truth table, that would fall under the first category here. True and true, that implies truth. So again, if true, then true implies truth. So we'll say true here. Let's say true. Okay, the next one, if dogs are fish, which is false, then dogs can swim, which is true, dogs can swim. So in this case, this statement is going to be true because our hypothesis, which is false, when we start out with a false hypothesis, then in the end our conditional statement is always true. So this is if false, then true, turns out to be true. Okay, so that's a look at the if-then statements. Again, here's the truth table. Here is just something good to remember. The only time it's false is when you start with a true statement and then your conclusion is false, and that's a false statement on the conditionals. Now, just a little bit of food for thought when you look at these truth tables. This is not something you're going to be doing in this lesson, but just know that these truth tables can get more complex. And when you're looking at trying to prove something, especially in a mathematical proof or prove a logical argument, here's one when you look at it. You can start with two propositions P and Q. You can look at not P and not Q and their values. And then you can start to do all sorts of fun things. You can do, for example, if P then Q. And notice that if you compare if P then Q to if not Q then P, you get the exact same truth values. True, false, true, 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 false, true, true. Okay, this is what's called contraposition or contrapositive. Okay, it's just a unique thing to look at, and this is just food for thought. And then if you look at what's called the converse, which is instead of if P then Q, you look at if Q then P, that is the same as the inverse. If not P, then not Q. Those are equivalent as well. So again, these truth tables can be built out much bigger than we have, up here, for example, in our truth table here. But these can be just used for bigger arguments. You can use them to prove things in different ways. Just again, food for thought, something to think about, but will not be covered in your homework in this lesson. But if you do have any questions on the other things, please do not hesitate to let me know. Hope you have a great rest of your day.